Okay, let's remind ourselves about some of the concepts that we came across this morning. Mano Mesa. Enam.
Yeah, hello.
Hello, Enam.
So I remember talked about um we talked about joins, we talked about, well, in general, some more SQL commands or queries. So we talked about joins, we talked about minus, we talked about left join, right join, the full join, and how all of them can be used to basically get the results that we need for whatever purpose we need it for.
All right, thank you, Enam. So, prior to today, we had only been making queries on one table, and today we looked at, this morning we looked at how we can aggregate or how we can group queries from multiple tables. We spoke about the
I'm here. Sorry, I was outside. I was using an airport, so I couldn't answer.
Oh, okay. Do let us know what you remember from this morning's session.
So this morning we were trying a few of the SQL workloads. We did just like my brother was saying earlier on about the joins and the union and other ones. And we said the join, sorry, is used to combine either two or more tables, and the union for two or more queries. Yeah.
All right, thank you, Ima. So yeah, we looked at how we can use join to combine data from two or more tables, and we also looked at how we can use a clause like union to merge or to aggregate the like multiple queries. So for example, our select query from table 1 and then a select query from table 2. We saw that we can use union to have my SQL or to have the database retrieve or show to us. So inside of our output, we'll see that those two select statements have been run as one. And so both results from those two queries that we made would be shown to us. And Ruben.
Yeah, so we are still on join. So with join, we also talk of union or. That's with union or the tables that need to be joined. That is the result the result of the data needs to be joined without duplicates. So that is what I also learned.
All right.
Thank you.
Thank you, Ruben. So the difference between the union clause and then the union or clause is that when you use just union, you would be given results without duplicates. And when you add the all keyword to union, then you would be able to get duplicates inside of your query or inside of your output. And in our example, we saw that we had multiple Emmanuels and multiple Derek's. So when we ran those two commands, we got different outputs for them. Gifty.
Okay, Akosia, so from all that everybody's saying, we treated ordering data. So by clauses that we can use to order our data could be group by, order by, having. Yeah. And then And today too, we looked at the AS. I don't know whether it's a keyword or the as, yeah, that we can use to create aliases for columns. Thank you.
All right, thank you, Gifty. So we under organizing of data, we looked at some clauses like order by, which we used to sort our data in a specific column. So ascending or descending, by default, it sorts in ascending order. But if you want a different order, you can specify DESC, and for ascending, you can also specify ASC. We also looked at group by. This is the clause that we use to group, or we use to categorize our results. So if we should search for some rows, or we should query for some rows and they're given back to us, we do not want to just see those rows individually, but then we want to see the group or the category that those rows that we have queried, or those values that we have queried, fall into. So it would be able to return that result to us based on how, or based on the column that we want the column that we want SQL to group these values by. And we also mentioned how we use the having clause to further filter the groups that the group by clause would be able to display to us. Dennis.
Yeah, so we also looked at some set operators, and we looked at the usage of the union or intersect, and then the minus functions in querying data and organizing, or bringing up a specific structure in the database.
All right, thank you, Dennis. So yeah, still on multiple tables and how we can get our queries to bring us results from two or more tables. We looked at some set operators, union or intersect, and minus. Okay, so so the next two modules inside Canvas are RDS and DynamoDB. So I'm hoping we finish that this afternoon and we can close the chapter on database. There's an assignment on database though, so just these two, and then I give you assignments and then we're done with databases. Okay, let me share my screen so we start with RDS. Okay, who can draw a comparison between it doesn't have to be specific to AWS, but what I'm looking for is if you were in a traditional data center and you wanted to have a database, or you want to host a database. So in the traditional sense, what are the steps that you would need to go through? Because we've been working with Workbench all this while, because I was able to use my laptop to host a database for us where we could have our students and trainers tables. So in a traditional setting, who can just give us a summary of the steps we had to go through to have that happen for us? And
I think you just have to, well, basically, if you have your server, you just need to download the setup like we did, and then go through the steps to install, complete the installation, set up your passwords, and then you can, so it will provide you with a means to either connect the database on application, or you can manually input the data with your queries and stuff like that.
All right, thank you. And so the first thing he mentioned was that you need to have your server or your computer, which in our example, I used my laptop as the server, and then we went on to use the MySQL installer to get us the MySQL server, which is responsible for which the MySQL server is what is actually hosting our database. So that is the RDBMS that I am using to provide my server, which is my computer. Okay, so my computer yet didn't have any database functionality till I had to get that RDBMS. So we went to the site together to go and download that. And then one of the products that this RDBMS came with is Workbench, which just provides us the graphical user interface that we can use to make queries. So you get your server, you download the RDBMS to be able to help you with queries. And depending on what you are going to be using that database for, there would be more functions. So this is a traditional setting. This is how we went about it earlier. So with the cloud section, we are, as usual, we are renting resources from AWS, okay? And these resources that we are renting today, we want to use those resources we are renting to host our database. So RDS is a service that helps you not to worry about the server provisioning. You do not worry about the RDBMS. So in the sense that you do not need to go to the MySQL or Oracle websites to go and download the RDBMS. No, RDS, which is Amazon's relational database service, will take care of all those things for you because it's a fully managed service. Okay, so the steps that we had to go through, let's say I didn't even have my laptop, so initially you would have to buy your server, all of those things. RDS helps us to eliminate all of those things. So what is Amazon RDS? It's a managed database service that sets up and operates a relational database in the cloud. So prior to up to now, we have been operating our relational database on my my PC or on our individual PCs, those of us who were able to download MySQL. So running an unmanaged standalone relational database can be time consuming and it could also be limited. So to address these challenges, AWS has provided this service and it sets up, operates, and scales the relational database without any ongoing administration. So looking at scale, if the data that I'm keeping on my local machine, like in Workbench, when this morning I did some demonstrations, I keep getting additional data, and my space is being maxed out. My option would be probably to provision a new machine or to yeah, so my options would be to provision a new machine or to get some additional storage for it. And all these are going to come with costs, and it's also going to take time for me to go and do those things. But with RDS, with a just like a few steps inside of RDS or a few clicks, it will just be able to scale. So we probably started up with just not a lot of data. And as time goes on, as that data is increasing, RDS would be able to scale to meet those demands. So if my data is increasing on my machine and it's maxed out, I really don't have any option than to get myself probably another server or something of that sort. But in the cloud, you'll just be able to scale or let's say expand more easily. And so because you are not focusing on these administration tasks, these operations, scaling, server provisioning, so you have the chance to focus on the data that is inside of this RDS service. So you are able to just forget about those administration activities, those patching, updates, all those things, but all you focus on is the data that you are putting into RDS. So RDS frees you to focus on your applications so that you can give your applications the performance, high availability, security, and compatibility that they need. With RDS, your primary focus is your data and optimizing your application. So these are some use cases for RDS for web and mobile applications, and some reasons why RDS is preferred or recommended, or how RDS helps with web and mobile applications is because it has high throughput. So when we talk about throughput, we just mean the rate at which transactions can get completed in your database. So while your database is running, a lot of transactions are taking place. So for example, you're hosting a social media app, and so you're hosting a social media application, and then a lot of people are making transactions at every time. So there are millions of transactions. People are texting, DMing, people are posting. There's many transactions happening at the same time. But because RDS has high throughput, you would be able to have all those transactions happening at the same time, and your database will not crash because it's able to handle those high volumes of requests. RDS also has massive storage scalability. So as more data is being compiled or as more data is being entered into or written, the word is right. So as more data is being written into your database, RDS just scales. So it's able to expand to accommodate as much data as you need. And RDS is also highly available. Who remembers what you said in this class before about high availability? I think I mentioned it when we were treating S3. And I mentioned how some standards of S3 are cheaper than some because those standards offer a higher availability. Guys, high availability.
Please, can you repeat the question again?
I'm asking if anybody remembers what we've said about availability, high availability before. So I remember when we were treating S3, I mentioned that for some of the classes of S3, you'd pay more than some because, yes, so two particular ones come to mind. And
Yes.
because, okay, so because the cheaper one is not highly available, because that cheaper one is in only one availability zone. Thank you, Yakubu. So that is what high availability means inside of AWS. You are provisioning your resource inside probably one of the regions inside one of the availability zones inside US East 1. But what RDS offers you is that it replicates or it makes backup copies in other availability zones. So you are rest assured that let me just enter this. Okay. So each region has multiple availability zones, at least 3 availability zones. So if, for instance, you're operating in your database is inside this region, and the availability zone that has your database instance or that has your database, AWS behind the scenes would create kind of like backups in other availability zones. So let's say US East 1A is the availability zone you're operating in. So you might have a backup in US East 1B or US East 1C. So that's what we mean by high availability, multiple availability zones. So that's way whenever anything should happen to your main availability zone, everything is not lost. You would still be able to retrieve whatever data that you were storing there, which helps with data availability. So that's high availability. And another use case for RDS is e-commerce applications. E-commerce applications include Jumia, Ishtari. So those applications that you can go or you can log on to and do your shopping. That's what we mean by e-commerce applications. And it provides a low-cost database. So when you compare or when you juxtapose to how you would run it traditionally as compared to how you would run it in the cloud, because RDS or in AWS in general offer a pay-as-you-go pricing model, it is actually cheaper to use RDS most times than to host your database traditionally. And it also offers data security. So there are features like encryption, network isolation. So with regular backups, password. So we'll be demonstrating RDS today. So you'll be able to see that you'll be able to set a password for your database, and it also integrates well with IAM. So people in your account too are also checked, and to make sure that every connection or every access to your database is an authorized one. And I've spoken about encryption too. So when data is being written to your database or when the data is being retrieved, you could, or RDS offers encryption for that data. So even if you have customers with sensitive info inside of that database, it's secure. And another advantage is that it is a fully managed solution. So especially so for example, as compared to EC2, if you have an EC2 instance, you would need to be performing patches, software updates. You need to, so let's say we wanted to run our database using EC2. Okay, what we would have to do is we would have to run the sudo apt and then install the MySQL. So we would have to do that. If there are any updates for the MySQL, we would have to make those updates. But with RDS, it's fully managed. All those things, we don't need to do them. All what we need to do is to take, when we are creating the database, we just take what we want, and then AWS behind the scenes just provisions everything that we have specified. Another use case too is mobile and online games. And one advantage is that it has rapid growth capacity. So as your data is getting more, RDS will just scale to meet the demand. Also automatic scaling, also on the same point, and database monitoring. So RDS integrates well with CloudWatch, so you would be able to monitor certain metrics that you specify. And we know in CloudWatch we can also set alarms. So whenever anything is going on inside of your database, you'll be able to respond in time. And RDS too does not have any licensing constraints. And yeah, you do not need to worry about provisioning, scaling, and monitoring your database service. You can set RDS up to be doing all these things for you. So a database instance, what is a database instance? It is an isolated database environment that runs in the cloud. So we know what instances are, right? Virtual machines. So a database instance, it's your virtual machine that you know, just that it has been optimized to run your database environment on it. So that's what we mean by database instance. So more on RDS DB instance. You select your instance class, which has to do with the CPU you want to use, the memory you want to use, and the network performance. And you also select your instance storage, your DB instance storage. These are the options available to you: magnetic, general purpose SSD, provisioned inputs, outputs, operations per second. So depending on your use case, especially if you're going to be getting a lot of writes to your database, going for the provisioned will be your best bet. And then general purpose is it would usually be used by companies or users that are starting out. So you can just provision a general purpose SSD to use in the meantime till you're able to know the exact or to determine the exact special use case that you need. Then you go for a different storage type. And with the instance class too, it's just like how when we are provisioning our EC2 instances, we have instance types. So T2 micro, T3 micro, all of them have the various CPU, memory, and performance that they come with. So that's kind of like the same idea here. And the types of database that you can host in RDS, we have MySQL, Aurora, Microsoft SQL Server, PostgreSQL, MariaDB, and Oracle. So when companies who have been hosting their database traditionally are moving to the cloud, these are some of the things that they look out for, because if the DB that I use, for example, is MySQL, and I come on and I'm moving to RDS and I do not have or RDS doesn't have that option for me, then my move to the cloud it won't be worth it, because that's going to be cumbersome. So there's have to be extra work to be done about it. So these are some of the popular database types that are used around the world. MySQL is actually the most popular. So RDS has these options available. So whenever you need to start hosting your database in the cloud, or you need to migrate your traditional database to the cloud, these options will be there for you. They are compatible, so you'll just be able to move, and it will not feel like you have it will not feel like anything has changed. So the basic building block of RDS is the DB instance. And the resources that your DB instance has is determined by the class and then the type of storage that you are attaching to it. So the various DB instances differ in performance characteristics and price. So you can customize the performance and cost to the needs of your database. So when we go to the console, you'll see, so for every configuration you make, it would show the amounts that you would need to be paying. So even before you click on create database, there would be a summary of how much costs you're going to incur. So you will look at your needs, and then based on your needs, you will select the performance that you want, and RDS will just calculate it for you so that you know the cost to expect. I think it's monthly or something. So yeah, and these are the database types that are supported on RDS. Yakubu.
Yeah, so the storage, I don't really understand the difference between these ones, the magnetic, the SSD, and then the instance store, the elastic block store, the S3. I don't know if you understand the question. It's like this is also a class of storage, magnetic, SSD. So, and then I thought that for the, how do you call it? For Amazon, their classes of storage are the S3, the block store, the elastic block store, and then the instance store, and then the file system, EFS.
Those are the storage services that S3 offers. Sorry, AWS offers. So S3, EFS, EBS, well, Instance Store is not a service, but Instance Store can just be used with your EC2 instance. So depending on what service you are in, the storage options available to you differ. So when you come to RDS, for instance, I think I passed storage. You won't see something like Instance Store. You would see EBS storage because EBS storage persists, okay, and Instance Store doesn't persist. So when you stop your instance, you no longer have that information. But for a database, we need storage that persists. So one of the options would be those that we just saw. So instance configuration. So the storage options, cluster storage configuration. Okay, I'm not seeing the storage options, but yeah, so depending on the service that you are using, that would determine the storage options that you have. And
Okay, so can I add on to what you said?
yeah, go ahead.
Okay, so I think the difference here is that with the other storage services, you can basically decide what you want to store in those or within those services. For example, if you have maybe a video file, an audio file, or whatever, you can store it directly in that storage service. And it is not stored in a database. But then with this sort of storage, the idea is that you always have to, your database cannot exist without storage. A database is basically an organized form of storage, okay, where everything has like a name or a description or something that can be used to identify it. So the difference here is that this type of storage is dedicated to your database and only your database. So if you're uploading something into it, it means, or it's assumed that you're uploading something into your database. For example, if it's a video file, you can't just upload a video file onto the storage service that the RDBMS provides. You have to upload it into the database as maybe, let's use an image, as maybe a DP or a profile picture. You get, so that the database can identify it as, okay, this is Yakubu's profile picture in the database. And if you want to retrieve it, then it goes into the database and then retrieves it for you. I'm done.
All right, thank you. And depending on the database type that you use. So when I came here earlier, it was Postgre that was selected. So in our case where we use MySQL, when you come under storage, you'll be able to select what storage type that you want. So the general purpose SSD, it scales, the performance scales independently from storage. These are like additional details to help you, to guide you to the particular storage type to use. But inside of RDS, you would be using the EBS, just that you won't choose EBS like how you choose EBS when you are configuring your instance. But under the hood is EBS that you're using, because this is an instance, like a database instance. Yakub, is that okay?
Yes, please. Okay. Thank you.
You're welcome. Yeah, so the particular storage that you would use would depend on your use case. RDS backup. So we have the automatic backup in RDS, and we also have the manual backups. The automatic backups, they create automated backups of your database instances during the backup window. So when you're configuring your database, there's an option for you to choose this backup window. So probably the users of your platform or the users of your app or whatever you are building or whatever you're marketing or selling. So let's say you are at Facebook. So the users of Facebook probably at 10 p.m. what's it called? The traffic or the demand or the load coming in goes down. Okay. So you might want to put your backup window during that time. Another option too is to get two database instances, so that's while one of them is, so you set their backup window to be different times, so that while this one is updating, your users can be routed or can be served with the second one. But because AWS has to be making updates and patches for you, you are going to have to specify when AWS should come and do those updates, patches, and maintenance work inside your database. So that's what the backup window is for. And for the automatic backup, AWS does so within that window, AWS will come and take the backup of your data and your transaction logs. And with the manual one too, that's when you yourself want to create a snapshot of your database instance. So when you go to RDS and the list of your databases are there, you just select it, and then under actions you select the create snapshot. So when you create the snapshot, what it does is kind of like a backup for you. So if anything should happen to your instance, you still have your information, which is your data and then your transaction logs. And these backups are robust enough that you would be able to restore any you'll be able to restore your database from these backups that you've taken, these snapshots that you've taken of your volume. Yeah, so AWS performs the periodic backup of your DB instance, and it's all backed up to a volume snapshot that you specify the backup window. If you don't specify it, so they would have their own backup window that they would use. And you set a retention period. So each backup that is taken, or each screenshot that is taken of your volume, how long should it be retained for? So should they keep it as far back as a year? So if you want backups from a year, would you be able to get those? So you you specify the retention period. And the first snapshot of your database contains the full data. So if I bring back our Excel sheet, okay, let me use the groupings. So for example, today being 4th July, we had, let's see, just rows 1, 2, 4. Okay, so we are hosting this data inside a database in the cloud. So RDS is hosting that data for us. Now, with the automated backups, on the first day that this backup is taken, or the first day that AWS comes to backup, it would take the data that you have for that day. So just for an example, we just have up to row 4. Okay, so that's what it will take. Now, on the next day, when it comes to take another backup, it would back up anything that has added. So today we have this, and then tomorrow we come and add this. When it's coming to take the second snapshot, it will take what you've added, the updates that have been made to the database, and not the whole database itself. And please, is that okay?
Oh, no.
That's okay.
Derek, did you say hell no?
No, I think no, well noted, please.
Is that well noted? Oh, okay.
Sorry about that.
Oh, don't worry. So yeah, the first snapshot is your full data, and then any additional snapshots that will be added, they are incremental, and then they only contain the data that has changed since the most recent snapshot. So any changes that you have, it would record those changes rather than having like the full data. Musa.
Yeah, so assuming you change a name from maybe a data, right? And then it comes to pick the new information, it will overwrite the old one that you can't go back to that particular data anymore. Is there a way you can just configure to have a versioning, like hit that one and then put a new version for?
Okay, it won't overwrite it. It will keep them as backup files. So backup on this day, backup on this day, backup on this day. So it doesn't overwrite it. Your initial backup, which is your full data, is still there. And then the incremental backups are just changes that you made after you've gotten that full data. So it's various different files, though it's of the same database, but it's different files.
Okay, thank you.
You're welcome. And so that's with how AWS automatically does the backups for you. And your other option too is to back up the database by yourself. You select the database, go to actions, and then you create a backup. So it's called a snapshot. So you create a snapshot. John.
Hello, Akosia.
Hi, John.
Yes, okay, so good afternoon, and good afternoon to my friends.
Afternoon.
Yes, we're talking about incremental backups and then your full backup. So if there is any situation that happened and you think you wanted to restore from backups, just as I think it was Musa who asked that, is it going to overwrite or whatever it is? It means that you should actually know the date for the last full backup. And then you should also maybe know about the last incremental backup or whatever happened.
Yeah.
Because I'm thinking, if you are just restoring the last incremental backup, it will just be the last incremental backup, if that were the case. Or that you take the full backup, you restore that, and then you run the last incremental backup to actually synchronize the data and then add the last incremental backups on to the full one to make it a set. Is that the way it should work?
So yeah, you would have to restore it from the full, and then the incremental ones will also be restored after the full has been restored.
So it is not that you think that, oh, yesterday we did some backup, so you take it and you restore that. Then it will just be only the incremental backup for yesterday, and then the rest is something else.
Okay, so let's say we have this table, okay, and then the full day, it got day 1. And then the second day, it got day 2. So the second day's data would be containing day 2, okay? And then the third day's data would be containing day 3. If you should only install your latest one in addition to your full, you would lose what is in the middle.
Okay.
So you need to install like all of them. But that's the way that Amazon or AWS does their backup. What you can do from your side is you will take a full backup. So that's when you use the manual backup feature, where you would take a snapshot of your full data. So it's AWS's own, which is the automatic one, that is incremental. But you also have the option to take a full one. So when you want to restore, you can always, so let's say you took a full one on day 3. So when you want to restore, you can just restore that day 3, and then you get your 3, 2, 1.
Okay. All right. Thank you very much.
Thank you too, John. So these are some links that you can visit if you want more information on backup and restoring of your Amazon RDS DB instance. The easy create method in Amazon RDS. So if you come to, let me go back to RDS. So if you come to your RDS and you click on create database, there are 2 options for you to create your database. Standard create, which is it includes all the configuration options. So if you want more control over the details or over the configurations that your database is going to have, this is what you go for. And then you could also use the easy create, which has less options. And so the rest of the options that you don't select, AWS would give you the best, or like those good default options that they have for easy create would be probably if you're experimenting and you don't really know the configurations or the details that you need for your database yet. So easy create will be able to help you to quickly put a database together, and standard create gives you more options to choose from and more control. Okay, so the easy create method in RDS. Yeah, so we're looking at a sample configuration that uses easy create method to create a database in RDS. The easiest way to create a DB instance is by using the management console. And after you create the DB instance, you can use standard MySQL utilities such as MySQL Workbench to connect to a database on the DB instance. So there are two ways to create so this morning we were still doing demonstrations on my local database, but later we would go back to Workbench and then we would connect the RDS database to our RDS database, and we'll realize that we can still use our MySQL utilities, our queries. We can run all the commands that we have been running this past week. So these are the two options, Easy Create and Standard Method. And when you choose Easy Create, the options that AWS provisions for you would be based on Amazon best practices. So the best practices are how things are done, like the best way that things are done inside of AWS. Okay, so it's like tips. And you can also specify the engine and the instance size and choose an identifier. Identifier is the name of your database. And you also have an opportunity to select standard create to create your instance. And with that, you determine or choose your configurations. So if you want to choose your configurations, you go for standard create. If you go for easy creates, AWS would use best practices to kind of just fill in those configurations that you didn't or that weren't offered for you to pick from. So how to create a database instance? Okay, let me share my second screen. Okay, so in the configuration section, you choose MySQL and then you complete the remaining steps that are needed to answer the required configuration questions, and then you choose create. Just leave everything on default. So we have a MySQL Workbench and our database, what to use there? The MySQL database. So would select that. I would go for free tier, and the instance identifier is the name of our database. So we can just call it restart. And the name must be unique across all the database instances owned by your account in the current AWS region. And the instance identifier is case sensitive, but is stored as all lowercase. And the constraints, they can only contain 1 to 60 alphanumeric characters or hyphens. The first character must be a letter, and it cannot contain 2 consecutive hyphens, and it cannot also end with a hyphen. So as you're making your configurations, we are even using Easy Create, and these are the configurations we have to make. So these are just information for you to take note of as you create your database instance. So the login ID, I think we can leave it as admin. And then we would create our own password because we haven't done Secrets Manager yet. So you can have RDS generate a password for you, or you can just use your own password. So you can set up an EC2 connection after creating the database. So RDS is managed and you do not need to do this, but probably you have some configurations and changes that you want to make inside the underlying or you have an EC2 instance that you want to connect to the database. That's when you would use this option. So after creating the database, okay. So if you want to connect to an EC2 instance or not, a use case for this would be the 3-tier application that we saw when we were treating people who roles that's used databases. So if you want to connect your application server to your database server, so presentation layer, application layer. So your servers in the application layer, if you want to connect them to your database layer, that's when you would need to connect to an EC2. So when you click on connect, I will show you the EC2 instances that you have inside of your region that can connect to it. And so when you make that connection, a VPC security group is added to the instance, and a VPC security group is also added to the database with an inbound rule that allows the EC2 instance to access the database. So your security group, an inbound rule would be created and then put around your or guard will be created to guard your database instance. And what's that inbound rule is that it will be accepting traffic from your EC2 instance. Does anybody know the port number that's inbound rule in our security group would have? Okay, so the inbound rule would accept traffic from port 3306. When we're looking at our workbench, when we're setting up our workbench, I told you guys to take note of the 3306. So that's the port number for my SQL. And so because we're going to be expecting that traffic from our EC2 instance or from our presentation layer, when we select an instance, a security group accepting traffic over that port would be populated for us and be added to our security group rules. So we aren't doing anything like that. So go ahead. Just click on create database. Okay, so these are some default settings for easy create. I believe I have just one VPC. So it's provisioned inside that's one VPC I have. And the subnet group, automatic backups are enabled. The VPC security group, if the database is publicly accessible, the database ports number, the database instance identifier. So that's the name we give to our database. And then the engine version. So other details about your database are here. And if you can change them or not after you've created the database, that one too is also here. So the ones that you cannot change, if there's anything you want to do about it, then you click on standard create and then you fix whatever it is. Okay, so we can go ahead and click on create database. Why is that issue? I don't want to use a password that I'll forget to change that because I'm clicking create database and it's refusing to create.
Hello, Akosia.
Hi, Ma.
Yeah, but if you have a password manager, you can try that. Or
Password manager for
No, I'm talking about the password. You said you don't want to use a difficult one that you forget.
so I thought because my password was weak, that's why when I click create database, it's not working, but I changed it and still it is not working.
Why don't you type something in your notepad and then just copy it and paste it in? At least you know
I've
you have a copy.
actually changed it too. So after I said that and I changed it.
No, she's saying maybe there's a problem elsewhere, not the
Yeah,
password.
yes, I
Yeah,
don't think it's the
I'm not sure it's
password.
from the password. Yeah.
Please refresh the page and see.
Okay.
Agoza, I think you selected add EC2 instance. That's why.
Oh, okay, that's true. And I collapsed it. So even if they're showing an error there, I won't see. Thank you, Calvin.
You're welcome.
Self-managed. Okay, so now that it's not don't connect, I think it should work. Yeah, so when you're not being sent to the other page, what social would like the rights? I think a number of us experienced it when we're creating the S3. So where you enter your S3 bucket's name, the rights bucket name must be unique. So you won't be able to move on from that page. But then what happened here was that I had collapsed it. So they were given that error, but I just could not see. Okay, so we have database is being created. So databases take a while to create. So I think we can just leave this and then go back to the slides. We'll come and continue what we have to do later. So depending on the instance class and the amount of storage, it can take up to 20 minutes before the DB instance that you've created is available. So ours isn't, but we didn't provision any high performance one. So we went with the free tier. So ours will not take up to 20 minutes, but it will still take a while. So we'll check back soon. High availability with Amazon RDS. So RDS offers replication. So if you have your DB instance inside of one availability zone, it's the synchronous replication. A replication is happening at the same time. So if there's a write request, so let's say inside of the database, you add a new row inside your availability zone one. At that same time, it will also be populated inside your instance in availability zone 2. One of the main features of RDS is that you can configure a DB instance with high availability by using a multi-AZ deployment. So AZ here stands for
Availability zone.
thank you. So one instance here, one instance here. So 2 availability zones of the same region, and every write or every change I'm making here is replicating to the other instance in the other availability zone. So it automatically generates a standby copy of your DB instance inside another availability zone in the same VPC. After you make an initial full copy, transactions are synchronously replicated to the standby copy. So the full copy of the initial DB instance that you had is first populated in the standby. Then any changes that are made to the main instance are also replicated synchronously, so at the same time. And this helps to enhance your availability during planned system maintenance. So I mentioned how you can specify your maintenance window, and when you specify that maintenance window, your instance or your DB instance, which is your database instance, might be down for a while. So because you have two of them, you will be able to, or your users will still be able to access the database services on this, because this is just a replica of this. And in case of any disasters or any disruptions, you always know that your standby is there. So in this diagram, it has been configured to be highly available. And here, this is the primary instance, and this is the standby. So it provides data redundancy in the sense that everything or all your data are on this first one that you can get to do whatever tasks that you want for you. But then this one too has those same capabilities, and they're also here. So this one is being redundant. I don't want to say useless, but then it's just there. No, when this one has all the features that you need, but this one too also has all the features and all the data that this one has. So it's just redundant data. Okay. Yakubu.
Hello.
Yes, so if the database is being replicated automatically in a different AZ, then why do we need a backup?
Why do we need the automatic backups that RDS takes?
Yes, like initially we said we have automatic and manual. We can do it ourselves, or we can choose automatic. But then, however, now the database is being replicated in the first place, like it's being replicated elsewhere, and then we have to do the backup again.
Well, we don't need to do the backup, but RDS does these automatic backups. It's part of the service. So they are taking them, but yes, both of them serve the same purpose. In case of a disaster, you would have your data still intact for you.
Okay, but then the backups they are going to charge, right? Or they will not charge?
So the backups are usually stored in S3, so you pay for storage, but as part of the RDS service, the backups are included in the money that you are paying for the RDS.
So that means okay. So then we are paying twice for storage in S3 and then for the. But I'm thinking that if RDS is replicating the data elsewhere, then there will be no need to pay for another backup elsewhere.
So the backup is files, and then this instance is another instance that can save the traffic, but the backup is just files unless you restore the backup. So unless you turn that backup into an instance, it's not it's just like a screenshot of your data. So they don't do the same thing. If your instance should fail over, if your instance should go down right now, it will take a while. You now have to set up your backup to be able to serve your clients accessing your database. But in this setup, as soon as it fails, it will just fail over here. Is that okay?
Yes, it's okay. I understand the failover here. Yes, but what I don't understand is we having to back up in S3 whilst there's, an easier and simpler one happening here. Or I don't, maybe I don't understand what is happening.
I think you understand what is happening, but you feel like it's redundant because we have this one, we don't need that one.
Yeah, something like that.
So I think we can just look at it as double protection.
Okay. Maybe the two availability zones can go off.
Okay, yeah.
Yeah, okay. All right. Thank you.
You're welcome. Ellie.
Yeah, hello. So I wanted to add a little something in regards to what he was speaking on. Sometimes it's necessary to have these redundant backups because I think a month or two ago there was an issue where a certain firm, I think the name was Unisuper, they ended up mistakenly deleting their Google Cloud account. So they lost the main account, they lost the backup as well. But thankfully, they had an extra backup elsewhere. And that's where they were able to restore their data from. And this company is valued at around 125 billion USD. So that's a huge amount of money that we are dealing with when we look at their assets. So it's never a bad thing to play too safe with these things. Sometimes it will actually come in handy.
Thank you, Ellie.
All right. Thank you.
Welcome.
Mano Odum.
Yeah, thank you, Akosia. I think Ellie is spot on that, yeah. But I have a different question. I want to find out that the RDS that is replicated in the other AZs, don't they serve traffic?
They have been configured to serve traffic in case of a failover. So in the meantime, they're just redundant. They're just there.
So how does it make it the RDS highly available? So, okay, I'm asking that because what if one RDS is overwhelmed? It hasn't failed, but it's overwhelmed. I mean, is there a measure in place to have
Use
the
the
other ones?
backup.
Yes, taking care of the traffic.
You can always promote this one to also, so that means you have to route it to use both if that's the setup that you want. You'd have to configure it to use both.
Okay. So there is, I mean, the chance for you to allow both to serve the traffic.
Yes.
Okay, thank you.
Welcome.
Please, can we, like the question he just said, can we set up a load balancer, or it's only EC2 that we can set up load balancers? So if we can set up a load balancer on the RDS, can we do that?
I think we can. We should be able to. Okay, so in these examples, it's just one of them because one has failed. But then when we want both, we would be able to set up a load balancer for them.
Okay.
Yeah, so in this first example, these two apps, so your application layers with this instance in availability zone 2 and availability zone 1, both of them are using this database instance for their writes and then their read operations. So this one is just there redundantly, but the replication is happening that everything is being replicated. So everything that's happening here is also happening here. And when there is a failover, or when your primary database instance fails, RDS automatically brings the standby instance online as the new primary instance. So this now becomes the one in your EZ2 now becomes your primary instance, and the requests from both applications are then directed to this new primary instance. The requesting applications use RDS domain name system endpoints to reference the database by name. So you would register your instances. So probably it's not just 1, 2 that you have, but you could even have multiple. And you would register all those database instances to the RDS domain name system. So when that's RDS domain name system is receiving traffic, and then it senses that its primary or the resource inside of it is down, it will be able to just direct it to another resource because we have registered these instances to the same domain name system endpoints. So when anybody should query for that database name, it will bring them to ideally, we'll bring them to your primary. So right now, this is your primary. So it will bring them here because this one has failed. But your clients or your users just use the same name and it brings them to the same instances. And the failover happens without needing to change your application code. It's automatic. It just happens when the instance fails a health check. That's how it will be able to tell that the instance is down. Also, there is no data loss because of the synchronous replication. So everything that was happening here was also happening here, or it's also happening here. So when you fail over, you just continue from where you left off here. So in that case, there will be no data loss. Dennis.
Yeah, I want to ask, can an RDS be configured inside an EC2 instance, for instance, like as a virtual server, but then the server is also serving an RDS service, like within the instance? Is it possible?
Yeah, you can. It's called custom RDS. So when you want to have more control over your RDS DB instance, you can do that. But that's only compatible with MySQL and the Oracle. It's just compatible with 2 of the database types.
Oh, okay. And then also, when we're provisioning this, I didn't see any option to add it to a subnet. I only saw the VPC. So,
Yeah, so because we used easy creates, AWS chose a default. I think I only have one VPC in my account. That's what I'm suspecting. So it chose that VPC, and then out of the subnets inside that VPC, just chose one of my subnets.
oh, okay. So in the case where you don't have a VPC, would it auto create one?
It's not possible that you don't have a VPC in AWS.
Okay. All right. Thank you.
You're welcome. So even people who have never opened their VPC service before, when you go there, you see that there's a default VPC. So each AWS account that you create, they would give you a default VPC. I think the IP is 172. That's what it starts with. So everybody has a default VPC. Some scalability with RDS. So what do we understand by scalable? Scalability, scalable, scaling. Paris.
Abuja, please, the ability to expand our database.
Thank you, Paris. So scaling, being able to meet the demand or being able to meet your needs, how would you scale? Would you have to scale in? Would you have to scale out? Would you have to, in that sense, would you have to reduce your resources? Would you have to increase your resources to meet whatever demand or whatever needs that or requests that you have coming into your database? So Amazon RDS, read replicas, and scaling. So additional features of read replicas are asynchronous replication and So when we talk about read replicas, earlier today we performed some queries on our database, right? And all this week we've been performing some commands, exhibiting some commands. So these commands or these things that we want are guys, please give me 1 minute. All right, I'm back. So these commands that we run, some of them are write commands, some of them are read commands. And what we mean by write and read commands are that with write commands, they go and change something inside your database. So they go and alter some data. And with read commands, they just retrieve some data. So who can just mention when a write command that we ran today or that we ran in this week? Something that went to change something inside our database or inside our table. And
all the insert commands.
thank you. And so every time we run an insert, we are putting some data into our database. Okay, so what about the read? Who can tell us any read command we ran today?
Select.
Thank you, Dennis. The select command. What it will do is it will go in there. It won't make any changes. It will just go in there and retrieve some information that we are looking for. Now, depending on the kind of application that you are using, you might be having more write commands than read commands. And also the other way, you might be having more read commands than write commands. So read replicas are, how do I put it? They are snapshots or they are just a replica. So they're like, they're a replica of your database instance. So they look just like your database instance, but you cannot perform write commands on these replicas. They are strictly for read commands only. So you can only retrieve information from these replicas, but you cannot write to them. Please, is that okay?
Yeah, it's okay.
Okay. So an example use case would be if you have, for example, this, what's it called? This canvas that we are using. So the canvas that you guys are using to access your slides and those things, hardly would you guys need to make any edits to the database that is hosting these your slides. Okay, usually when if you should be making any queries to the database hosting your slides, it will be to retrieve the slides for you, but you can't make any changes to those slides directly. So in that case, a read replica can be provisioned, and that read replica has all the data that is on your DB instance, just that it can only retrieve that data for you, but you cannot make any edits to that read replica. So somebody who would want to make an edit would be probably somebody who works in the restart program. So probably the person wants to delete this RDS slide that we are looking at. The person wants to delete it from there and probably replace it with another one. So that is a person that would need to perform a write operation. But you and I, when we go to Canvas to go and get these slides we're looking at, we only need to read it. Okay. So we just need for the database to be able to retrieve what we are looking for. So that is one use case for read replicas. And you are able to promote the read replica to a primary instance if needed. And the functionality is for read-heavy database workloads. So when we say read-heavy database workloads, you have a lot of read coming in as compared to the writes. Okay, so it's just a a very read heavy. So almost everybody that is accessing your DB instance or your database, they're just coming to retrieve something. So it would be a good idea for you to use a read replica so that when anybody is trying to retrieve anything, they'll be directed to the read replica. And it has the ability to offload read queries. So our read queries are select is a typical read query that we've been running. So in addition to high availability configuration, RDS also offers other ways to provide scalability. For example, you can create read replicas for MySQL, MariaDB, Postgre, and Aurora. So these are the database types that are compatible with read replicas. So sometimes you can see in the exam that probably the solution would be for a read replica, but the database type that they've put there isn't one of these four. So you're going to have to look at other solutions. And updates to the source DB instance are asynchronous. Asynchronous means one after the other. So if the person inside the restart program, the worker at the restart place comes to make an update, it will take a short while for it to get to the read replica, which is the opposite when it comes to the high availability multi-AZ one, the DB instance that we saw. That one is synchronous. As soon as it's happening here, it's happening here. But with this one, it will take a short while before whatever is happening on the main instance would be made known or would be replicated inside the read replica. So it helps for you to reduce the load on your source DB instance. So your main instance, you want to reduce the load on it, use a read replica. And you route your read queries from your application to the read replica. You can also use it to scale out beyond capacity constraints of a single instance for read-heavy database workloads. And they can, so because they have the same information, that's this one, even though it's like slightly late to get that information, but eventually they will get the same information that the DB has. So if there is any issue, you can always promote the read replica to become an actual DB instance. Then you can be able to perform the writes on them. So because the replication is asynchronous, you would need manual action. So we saw in the multi-AZ setup that's the second DB instance or the redundant DB instance, as soon as the other one goes down, automatically the second one is promoted. But in this case, you would manually have to go and promote your read replica into a DB instance. And read replicas can be created in a different region from the primary DB instance. This feature can direct reads to a read replica in a geographic area that is closer to the user, and can also help satisfy disaster recovery requirements and reduce latency. So probably your main DB instance is in US East 1, and you provision a read replica in, let's say, the South Africa region, okay, because you would be expecting some traffic from Ghana or some traffic from Africa. So just to reduce the latency that those people in that region are facing, when we talk about latency, is delay. So just to reduce the delay that the people in Africa would experience when they are accessing your database, you just put a read replica closer to them. So that's another use for read replicas, to reduce latency. And also, it also helps in disaster recovery, because if this is in US East 1 and something happens, you have another read replica in a different region. I mean, it hasn't happened before that a whole region has gone down, but if anything like that should happen, you have a replica in another region that you can just promote, and then you just continue your work from there. So these are links if you want more information about scaling your RDS instance. And then more information too about storage types for RDS instances too. So you could visit this link, more information about read replicas. Okay, so RDS scaling. In Amazon RDS, the options you have when scaling, you can scale your instance class, which we can think of as just the instance type. So it will help you to increase your computation and your memory capacity. And you can also scale your storage capacity for your existing instance. So well, you just have 100 gig and you want to increase it to 200 gig. So you'll be able to increase your storage capacity without incurring downtime. So when you want to perform these two, So when you want to perform these two scaling options, you need to note that if you are trying to change your instance class, that would require downtime. But if you're just trying to add more storage, so it's like let's think of it as our laptops, okay? So we trying to change our instance class would be trying to change our RAM, our CPU. So for that period, our laptops would have to be off, let me say. And then for storage capacity, we can think of that as trying to increase your hard disk, your hard drive. So you want more space on your hard drive. And inside of RDS, you do not need to, your DB instance doesn't need to have a downtime for that to happen. So you'll just be able to get extra storage capacity or additional storage capacity without you having to have your database go down for a while. So these two ways that you can scale. The first one, which is the instance class, that would affect the rates at which your read and your writes are happening. So if you have an instance class that is highly performant, okay, your read and your write transactions will just be going through quick. That's like more like high throughput. And if you have storage capacity too, you'll be able to get more rows or even more columns. So you'll be able to hold, your database will be able to hold more data. So this one has to do with the transactions that are happening on your database. If you have a more expensive or higher performance instance class, then those things will be able to go through quick. And storage capacity, if you have more of that, your database would be able to hold more data. Okay, so there's a demonstration video from Canvas. I think it's about 8 minutes. But unfortunately, I think it's an old interface. Amazon RDS is available on several databases. Yeah, so the interface is an old interface, but I think you should still watch it because the points or the information is still the same. It just looks different. And earlier I went inside of RDS and I did some demonstrations, so you guys will be fine. So let me just share my sound and then play that video. Okay, this is it.
can we hear?
Yeah,
Yes,
we can hear.
yes, you can hear.
Okay, something there.
Hello, and welcome to this Academy Cloud Foundations demonstration. In this segment, we're going to be speaking about Amazon Relational Database Service, or Amazon RDS. Amazon
Please, we can't
RDS
hear.
makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your applications so you can give them the fast performance, high availability, security, and compatibility that they need. Amazon RDS is available on several database instance types, optimized for memory, performance, or input and output. It also provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and Microsoft SQL Server. You can use the AWS Database Migration Service to easily migrate or replicate your existing databases to Amazon RDS. In this demonstration, we go through the steps of creating a MySQL database using Amazon Relational Database Service and the AWS Management Console. We then connected the database in AWS using a MySQL client running on an Amazon Linux EC2 instance. So we are at the console, and we're going to be navigating to the RDS landing page. Once we are on the Amazon RDS landing page, we focus our attention on the orange button that says Create Database. We also notice how the left navigation panel has a number of items related to snapshots, automated backups, query editor, and others. These items are a little bit more advanced, and we suggest that you explore them individually to become familiar with what is it that they do, what benefit they render to you. We're going to click on Create Database. And on the following panel, we get to select the engine that we're going to be using. In our case, the MySQL engine. We get to see Amazon Aurora, MariaDB, Postgres, Oracle, Microsoft SQL Server. In this case, we use MySQL as it is a common database implementation for LAMP stacks. On the MySQL configuration, we're going to click on Next. And RDS gives us a way to be able to choose what type of use case are we going to be applying in this particular case. In our case, we're going to be generating a development and testing database. And we're going to make it applicable for the free usage tier. We're going to click on Next after that, and we get to answer some questions related to this particular database instance. Scrolling down a little bit, on the DB instance class, we're going to scroll up and select T2 Micro. That's going to give us a database engine that's actually applicable for the free tier usage. Because this is a development database, we're not going to be doing multi-availability zone deployment. Normally, that is reserved for production, where you have a master instance and a standby instance receiving changes and copies of what has changed in the master in a synchronous type fashion, meaning as fast as possible. We're going to leave the storage exactly as is, and we're going to be disabling the storage auto-scaling. Notice how the panel for estimated monthly cost gives you an estimate of what you will expect to pay for this particular implementation on a monthly basis. On the database instance identifier, we're going to give it a name. For master username, we're going to be selecting admin. We're going to be providing the master password and confirm it and click on Next. Following that, a number of advanced settings come into play. As far as the virtual private cloud that we're going to be using to land this particular RDS instance, we're going to select Lab VPC. The subnet group, we're going to keep the same. And for public accessibility, we already have it checked. We don't want it to be publicly accessible. We have no preference for availability zone. However, on the VPC security groups, we have pre-provisioned an RDS security group, which is actually open for the MySQL port 3306. The database name and the port 3306.
Okay, so please can you hear me?
Yeah, we can.
Okay, so for you to have the when you don't specify this database name,
Please, we can hear you speaking, but we can't hear exactly what you're.
You are not audible enough.
Yeah, it's like you are far away.
Yeah.
okay, so you finish watching the video, then I put my headset back.
Everything looks good.
Sure.
We're not going to be using identity and access management authentication, so that radio button is selected correctly. We're not going to be using encryption. And for backup, we're going to select 0 days. We're not going to copy any tags. And we have disabled enhanced monitoring. As far as log exports, we're going to leave everything as is. And we're going to be disabling AutoMiner version upgrades. We're also going to be deselecting enable deletion protection. That's all it takes. We're going to select create database, and that will immediately begin defining our database instance. We select DB instance details, and we get to observe the database provisioning. Initially, notice on the DB instance status, it indicates creating. We also get to observe how there are a number of CloudWatch metrics already prefabricated as far as being able to observe CPU utilization, DB connections, free storage space, memory, write input outputs per second, read input outputs per second. On the connect panel, under the endpoint, is where we will receive, once the database is available, the actual host name that we will be using to connect. At this point, we scroll back up, and we're going to be using the refresh button as a way of having the page refresh while we wait for the DB instance status to indicate available. Okay, we now get to observe on the info that the database instance, myACFDB, is marked as available. So we're ready to go and begin connectivity. As we scroll down on the endpoint and port, we're able to then copy and paste the hostname for connectivity to this database instance. We're going to be maintaining a copy of that RDS endpoint here on a text editor. Following this, we're going to be using the MySQL call to be able to invoke the command line interface to the MySQL database. Providing the password then allows us to begin to interact through the MySQL command line interface. We're going to be invoking some table creation as well as some data population of that table. So a total of 5 statements. The first one, create table, defines the schema, and then of course we populate with 4 names, last names, and phone numbers. All of the queries and all of the requests to the instance actually appear to be working correctly. Now let's do a small query to verify. Pasting a small query will give us the proper result. In this case, we're searching for Chris. We get first name, last name, and phone as a table. So we have successfully provisioned a MySQL database instance using the simplest configuration possible, including the database engine that qualifies for the free tier, using an EC2 instance running the Linux operating environment. We connected to that MySQL database, created a table, populated that table with data, and finally made a small query to verify. This concludes this demonstration for Amazon RDS. Thanks for watching.
Okay, I was going to speak on one of the configurations, but then I realized it's even different now in yeah, so I think we're okay, so we're here. So the RDS demonstration. What's his name? Jacobo.
Yes, Akosia.
Yeah, so were you the one who asked about load balancing and RDS?
Yes.
Yeah, so when you have the DNS names, when you register the database instances to the same DNS name, you wouldn't need to load balance it. It would distribute to those instances because they all share the same name. So
Okay, so when you register them to what?
to the DNS.
DNS, okay.
Yeah.
DNS.
So all of them would share the same DNS endpoint. So anybody trying to reach your database by that DNS endpoint would definitely be routed to one of the instances that you have.
Okay, thank you.
Welcome. Okay, so that's it for RDS. Are there any questions about RDS before we move on to Aurora? So Aurora is also another relational database, but it's not a service on its own, but it's kind of under RDS. So it's also another relational database. It's a database engine, AWS's own database engine, like how MS SQL is for Microsoft. Okay, let's start with Aurora. Aurora is a relational database engine. And some benefits of Aurora are that you can use the same code, tools, and application as existing on MySQL and PostgreSQL databases. So how we manipulate our MySQL database, we'll be able to equally manipulate our database that is running on the Aurora database engine. Database engine. So a database engine is a service for storing, processing, and securing data. And it would usually run on a database instance. So when we were creating, okay, the instance we created is ready. So when we're creating our database, these are the engine options that we had. So Aurora is AWS's own engine. And it's compatible with both MySQL and it's also compatible with Postgre. So depending on the database that's you're probably running on-prem or the database type that you want to use, that's when you choose this. There's also MariaDB, there's Microsoft SQL. These engines provide the database functionality. You can think of it as the shell and then the kernel. Okay, so we know that the kernel is the one that does all the work, and then the shell is just provides all the things that the kernel needs to do the work. If you guys remember your Linux, you should understand what I'm saying. So that's what Aurora is. It's not a database on its own, it's just an engine that runs the database, if that makes sense, like a manager of the database. Okay, so these are some benefits of Aurora. It's compatible with MySQL and PostgreSQL, and it includes a high performance storage subsystem. So when we are talking about high performance, we know that our transactions would be performed as quick as possible and as accurately as possible. And an Aurora database is created with clusters. When we talk about clusters, we mean groups. So a group of Aurora clusters. Yes, a group of Aurora clusters, or a cluster of Aurora instances. Okay. So an Aurora DB cluster, it consists of one or more DB instances and a cluster volume that manages the data for those DB instances. So inside of the cluster or inside of the group, you would find one or more database instances and a cluster volume. And what's this cluster volume is that it manages these database instances that are in Aurora. And the cluster volume is a virtual database storage volume that spans multiple availability zones. Each availability zone has a copy of the database cluster data. Contents of Aurora DB cluster. There are two types of database instances which make up an Aurora DB cluster. We have the primary database instance and we have the Aurora replica. The primary database instance is the main instance and it allows read and write operations, and it also allows for data modification. And what do we think the Aurora replica would do? Or what would the Aurora replica allow for? Quentin.
I'll say just to read.
Thank you, Quentin. So
You're
the
welcome.
Aurora replica, even though it connects to the same storage volume as the primary database instance, the Aurora replica only supports read operations. So some use cases for Aurora. For example, enterprise applications. So as compared to commercial databases, Aurora can help cut down your database costs by 90% or more while improving the database's reliability and availability. It's also good for software as a service applications because the software as a service companies can focus on building high quality applications without worrying about the underlying database that powers the application. It's also good for online and mobile gaming because these games are built to operate at a very large scale. And these games require a database with high throughput and massive storage scalability. Aurora provides enough room for future growth. So however large or however that your data needs to expand or your database needs to expand, Aurora has room for it. So any growth. Okay. What is one of the database engines that you can use in Amazon RDS? I think we saw about 6 on the console. So I want someone who hasn't spoken today. There's one very popular one. That's like number 1. Anybody should be able to say that one. Pensy. Emmanuel Janin. Albert. Hassanatu. Pardon? Okay, thank you, Hassanatu. She said MySQL. Okay, Perez.
Akosia, how
Yes.
were you able to hear and we didn't hear?
Yeah, we didn't hear anything. Oh.
So it was very faint, but my volume is on the highest. I think somebody else would have heard. Did anybody hear?
You don't hear the voice of them.
I heard it. I heard it now.
Yeah, you heard it. She said MySQL.
Hey.
It's long time I heard from him.
Hassanatu, please come and repeat what she said.
MySQL.
Okay.
Hey, you there?
Now we have heard.
Hey.
All right, Perez. Which one again?
Postgres. Postgres.
Postgres. Thank you. Gifty.
Aurora.
Aurora. Okay, Musa.
Microsoft SQL Server.
Thank you.
MariaDB.
Thank you. Kofi.
Oracle.
Okay, Oracle. And then the last one that's RDF have
Oracle.
available. Thank you. And IBM. So Aurora, MySQL, MariaDB, PostgreSQL, Oracle, MS SQL, and IBM. Okay, and what is Aurora?
Aurora is a musician.
Perez, kneel down where you are. Okay, Musa.
It's a database engine.
Thank you, Musa. So yeah, Aurora is a database engine, just like MySQL, just like Microsoft SQL, Postgre. So that is what performs the functionality. Database engines are what performs the functionality on our databases. So Aurora is compatible with both MySQL and then PostgreSQL. So you'd be able to use these MySQL commands that you and I have been running all week to be able to query a database that has Aurora running on it, running as its engine. So a database engine is the underlying software component that the DBMS uses to create, read, update, and delete data from a database. So I said we could think of it as shell and kernel. So the kernel is the one that does the actual work. And then the shell is what provides the kernel, provides all the other resources that the kernel would need to thrive. So that's it on database and database engine. Okay. So that's it for today. Ruben, is there a question?
So is that power the database, the Aurora engine?
Yes, so the engine does the so if you want to do create, is the engine that will go and do that create when you enter the query.
Thank you.
You're welcome. Mano Odum.
Yeah, Akosia, I have a question.
Okay.
When we went through Aurora, I noticed that it says it creates a cluster where within a cluster we have the primary and the replica. And then they're all attached to one volume, which spans across, all the availability zones within the region. So my question is, the other RDS or database engines like MySQL and Postgres, do they also behave in a similar manner, or it's only peculiar to Aurora?
So we know that for Aurora, that is what it does. But for MySQL, Okay, so when you're using my SQL on RDS, is that what you're asking?
Yes, please. That's what I'm asking. Because
So,
we get Aurora also from RDS, right? You only select that you want to use Aurora as the engine, database
yeah.
engine.
So
So
when you're
my question is,
using my SQL on RDS, you will get all the other RDS functions, which is the high availability, you get the scaling, automated backups, how like the ones that we've seen, that's what you get for all the rest. But it's only with our Aurora that you get this extra one. But then the rest of them, you just get the normal RDS functionality.
okay, noted. Thank you very much.
You're welcome. Okay, Yakubu.
Please, could you go over the explanation of the database engine and then the database management service?
Okay. So the DBMS and the database engine. So the DBMS is a system that helps you to organize your your data, your amount of data. And the database engine is just a function or a product that comes with the DBMS. So the DBMS is a broader idea, and then the engine is just one part of the DBMS.
Okay.
So the DBMS would be able to provide you for instance, the GUI that you use or the shell that you use. But what the engine does is the one that will execute the commands. So it's the one that will do all the heavy lifting, all the creating, the one that will create all those other queries that you need to perform on your database. It's the engine that will do it. But the engine comes with a DBMS, which is general management and general organizing of your whole database.
Okay, all right.
Okay.
So in this case, the Amazon RDS is the DBMS.
Yeah, we can say that it's a DBMS and more, because it also provides us with with the underlying instance or the server, which a regular DBMS would still need a server to do, but RDS will give us more than just the DBMS.
Okay, thank you.
You're welcome. Okay, so I'll see you all tomorrow. Tomorrow we'll do DynamoDB, which is the NoSQL database in AWS. Not plenty, like 5 slides, then we are done.
Okay, sorry.
John, I wanted to
Yes.
know if your
Mhm.
Linux thing worked. The link I dropped about the Linux. Let me check. Or you've not tried
I
it
haven't
yet.
sat down. I
Okay.
haven't sat down yet.
Okay.
But I'm coming to ask another question related to what we have done, the data manipulation language that we did, the insert, the
Yeah, go ahead.
thing. Okay. So sorry, my question is, so far I have seen, I don't know if you have talked about it or somebody have asked and it has skipped me or something. We have been entering, let's say, insert into, we're dealing with one table database. We had also seen the case where we had two tables that at some instance we would update this table by inserting into it, and then we also insert into the other table. But is there a way where with one insert, for example, we realize that we have a primary key here, we have its foreign key there. Would you have to insert data into this one and then go to the other table and go and insert
data into that one? Or is there a way where if you are inserting data, that could be common with common fields across, that you insert it at one time, and then two tables or maybe more get updated? Because I'm looking at a real life scenario.
Yeah, so you can't insert into two tables at once. So what you can do is, as you mentioned, they might be common data, or there might be some values that you want to insert in both tables. So what you can do in that instance is that you know the query tab, right? After we run queries, query is still there. So what you can do is, let's say you insert this into trainers, and you want to insert into another table. So after you run this one and insert into trainers, since you mentioned that it will be the same data, you would just alter the table name, and then you just run this again.
Oh, okay. Okay.
And
Okay.
if so I think you're trying to get at speed, right? How fast it will be for you to insert those data. So a faster way would be to import a CSV, which would already have those data, what's the word? Is it collated in the sheet already? So that's also another way to do it.
Okay. 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 Thank you very much.
All right, you're welcome.
Okay. Maybe the other thing, I didn't hear we talking about it. Even I don't know much about it, but I know something like that also exists in databases where we could have something like a stored procedure, which is also a component of the database system. And maybe after you have run an action on the database, can trigger some procedure automatically to possibly update other tables that are related or linked with the other tables, so that you don't have to do things maybe.
Oh, okay. So yeah, you can use functions for that, and you can also use the operators. So you just write your code that way. So if probably the source of the data or the source of whatever transaction you want to do is probably an API call. So when somebody on the front end or somebody in the presentation layer does this, what should happen behind the scenes is this command should run, this command should run, then those commands that you're talking about that would trigger something else, you'd run those commands to run. So maybe after the values are inserted, then you also want to add something and then create a new table with that something. So all lies in the commands, you compiling those commands and then setting a trigger. That's when that trigger happens, those commands should run. So it's possible.
All right. Thank you very much.
All right. Thank you too, John. And
Okay, so I wanted to talk about what John was asking about. Typically, when you are programming or when you're dealing with databases, especially relational databases, it's not good practice to store the same data twice. So what you would rather do is relate those two tables with something called a foreign key. So for example, if there's something called like a student, and you take the name, date of birth, and first name, last name, and everything, and you even maybe want to access it from another table, what you do is that you relate the student's table to the secondary table. Let's say maybe the other table is maybe football players, right? So imagine we have a school and there are students, and some of the students are football players, right? So instead of creating new records in the table called football players, right, which will have the same student names that are in the students table. You would rather link these two tables with the foreign key, right? So what you do is maybe your primary key in students is ID. And then you can also have an ID in your football players table. And then you say that, okay, the ID in the football players table is a foreign key that's related to the ID in the students table. That way, if there's a student with maybe the ID number 1 or 2, and the student is a football player, all you need to store is that student's ID in the football players table. So in the football players table, what you have is just 1 or 2, and that's referring to the student ID of that football player. I don't know if what I'm saying makes sense.
Yeah,
John.
it makes sense. John.
Hello, John. Okay, so that's what I wanted to explain. So you never
Okay.
really have to store data like that repetitively. It just slows down your application.
Okay. Thank you. And I think John is speaking, but it's very faint.
Hello.
Hello, John. Please speak up. We
Yeah.
can't really hear you.
Okay. No, I was saying that it's okay. I'm okay. Thank you.
Okay, so
Thank you.
I also wanted to speak about the updating thing too. So when you do, or when you use the foreign key principle, what happens is anytime you update the student's, maybe the student's name or something has changed. Whenever the student's name changes, you don't have to go to the football players table to make that same change, because it's just reading the value from the, let me say, the parents table. Okay, so that's how some of those things work.
All right. Thank you. And okay, I'll see you all tomorrow morning. Enjoy the rest of your day.
Thank you, Akosia.
Okay,
Thank you, Akosia.
Thank you.
Get the rest of your day.
Akosia, I hope you are fine.
Terry, I'm fine.
Thank God.
The end for all.
Hello, sorry, Akosia. Sorry.
Hi, John.
Yes, I want to ask a question and your view on it. From the latter part of this morning and understanding the fact that others are incurring costs in this AWS labs and all these other costs that is floating around. I'm asking, is it a good advice that you provision some particular service, you use it for your lab, you finish, you terminate it, and then the next time you have to do something else, let's say maybe every 2 weeks, you check and see whatever you were doing, if you are done, you terminate them. And then the next time you can provision those same things, and then you continue doing that. Because I guess it's becoming a case where folks think that, okay, if I have provided some EC2 instance, some EBS or something, so maybe I would check it and use it maybe the next week or something, and then they forget.
Yeah.
And then this thing, then it throws back cost. I'm asking this because of what happened to some of my friends. And then one YouTube tutorial or video I watched, after the man had finished with whatever he was doing, all he said was that, okay, guys, I have to clean up.
Yeah.
And then I saw he started shutting things down, and then so I want to find out if that is a safe way to remain in the free tier, because we are realizing that the free tier is actually not free tier in most instances.
The free tier is
And
not
I
free
don't know
tier in
how.
it.
Forget the
And I don't know how
list.
those
Forget to.
Yes, so what you need to do is every time you finish doing any practice, you need to clean up. You need to clean up because you are using it for demonstration purposes, and I'm sure the next time that you come back, it won't be the same thing that you come and demonstrate again. So, for example, when I was learning at ALX, what I used to do was I had a script. Okay, so if I want to provision resources to be able to do anything, test anything out or any assignment, I don't need to go and do the point and click. I just go to CloudFormation, I run my script, my resources will be provisioned for me. So every time I finish practicing, I can even destroy them from there. So they'll all get deleted. So I don't think the projects or the things that you guys have been doing so far entail anything really so complex. Maybe you just provision 1 or 2 instances. So when you are done, then you just shut them down. Even the next time when you come, you having to click and provision again, that's also practice. So just always shut them down. And
Okay.
another thing too is my personal AWS accounts. I hardly incur cost there because if, for example, I'm working on a client's project, they would have an IAM user for me to use. So I won't incur cost on my personal accounts. All the configurations and anything I have to do will be on the client's. So in this case, you guys are using it for labs, right? For practice of things about restarts. You've been provided labs to perform inside Canvas. And if you want additional lab experience, so there are resources like Skill Builder, AWS Educate, where you can practice more, especially when it comes to those ones that are not within the free tier. And you also need to familiarize yourself with the aws.amazon.com/free. So if there's any service that you want to use and you're not sure about if it's free or not, or even if it's free, what conditions is it free under, you would go to that website and you would also get that information so that you know how to proceed on your console.
Okay, thank you, Akosia.
You're welcome. So when you're doing your labs, you do them with the lab account that they give you, right?
Yes.
Okay. Because when you mentioned labs and then you mentioned the costs, I thought you were also doing it on your, like with your private account, doing the
Oh,
labs with your private account. So I just wanted to make sure that is not happening.
no.
Okay.
But I could
Okay.
say, I think with the labs, immediately you are done, it immediately terminates everything for you.
I think when you end the lab, so your labs use CloudFormation. So when you end the lab, it's supposed to run a stack destroy. So it's supposed to destroy everything.
Yeah.
But then the last time we were troubleshooting someone's issue, and then the person had their history. I don't know whether that's from cache or that's because their resources haven't been destroyed. I don't really know. But if you leave your lab for a while, I know you can run over the amount of so your labs are provisioned with an amount of money. So when you go over that amount, you wouldn't be able to go back and take that lab again. So right now you might not know what is happening till one day you go back and then they tell you that you've exhausted your resources for that lab. So let's just always be ending them.
Well noted, man.
Okay. All right, I'll
Coach,
see you
please,
guys
my
in the
greetings to
morning. Your greetings to
our host.
Francis. I'll tell him.
All right.
Bye.
Bye.
All right, sure.
Bye.